the most dominant harmonic, I want to say dominant harmonic is I2, second harmonic, second harmonic. Except in switching transient, all other dominant harmonic is third harmonic, but only in case of switching transient, this the dominant harmonic is second harmonic. You may ask reason how you can say it is dominant second harmonic. Without mathematical proof, I am going to give some conclusion. This can be proved by using Fourier series on this curve, that is finding an, bn. You can finally say second harmonic is dominant. But using the shortcut tricks which you have learned in Fourier series, I am giving some conclusion. See, if a curve, normal curve, this is normal curve, is symmetrical in x-axis and y-axis, x-axis and y-axis it is symmetrical, then it is having all its even harmonic equal to 0. Only odd harmonics not 0, that is only odd harmonics exist. Odd harmonics exist. Hope you are recollecting your signal and systems. So this curve has only odd harmonics. What you can say, if any signal is symmetrical with respect to x-axis, if any waveform is symmetrical with respect to x-axis, all even harmonics is 0. Or you can say any half wave symmetry signal, or you can say half wave symmetry signal, or any signal is symmetric with respect to x-axis, it even harmonic is 0, it have only odd harmonics. Okay, you will see this conclusion more in signal and system and power electronics. Now take, if any signal is unsymmetrical with respect to x-axis, that is this case, this is unsymmetrical up to this point, then it will have both even and odd harmonics. If something is symmetrical, it have only odd harmonics. If something is unsymmetrical, it will have both odd and even harmonics. So by that conclusion, I told you that I2 is dominant harmonic because it having both even and odd harmonics. Now take a case, third case, when it is symmetrical, you can say with respect to y-axis. Now you can say, see here, what is half wave symmetry means, this is first case. Now you take a second case, you shifted this here and take reverse. See, take this cycle, what you did, you shifted in another half cycle and you shifted reverse, you get negative cycle. That is x of t is equal to minus of x of t minus t naught by 2. That is, you shifted half cycle and took negative sign, it become negative waveform. Then it is called half wave symmetry. If it is half wave symmetry or symmetry with respect to x-axis, then even harmonics is 0. When you take x of t equal to x of t minus t by 2, see here I am not putting negative sign here. That is, if you are not just shifting the half cycle, if you shift the half cycle, it become like this. If you shift this, it will become like this. Which curve it is? It is full wave rectifier, or you take half wave rectifier. If you leave this area and shift for one cycle, you will get this area. Another shift for one cycle, you will get this area. Or for full wave rectifier, just shift for half cycle, you will get this area. So if you won't take negative sign, if this area is matching, then it will have all its odd harmonic 0, only it have even harmonics. You just, this all conclusion you will read in power electronics and signal and system. Try to analyze, try to recollect. You can prove this by using AN and BN term. Just go and watch that, once recollect the signal and system codes. So it will have all harmonics, odd harmonics equal to 0. It will have all its even harmonic equal to 0. Hope this 2 point is clear. It will have both odd harmonics and even harmonics. Now take a case, take a even harmonics. Suppose this is the case. This is an even function. For even function, you know, only cos term exists. Cos exists, sin is 0. Sin equal to 0. I am not telling that odd or even harmonic, here cos term exists, here sin term is 0. If you take this case, if you take this case, this is odd function. For this, you know, cos equal to 0, sin equal to not 0. That is, sin term present, cos term is 0. See, something with respect to x-axis, you will say that odd or even harmonics present or 0. If something with respect to y-axis, that is, you are finding even or odd function, then you will say sin or cos term present or not. Hope this clarity must be there. You must read in depth. When you read in depth signal and system, you will get this point as a clarity. If you don't understand, this is not my fault. Please one go and collect signal and system, because that is important here. We are going to deal in the next video harmonic also. See this is DC EMF, DC waveform, trapezoidal waveform. This is half wave symmetry. So due to this, all machine, whether it is a AC machine or DC machine, all the odd harmonics is 0. Due to symmetry, all the odd harmonics is 0. I am not telling that sin term 0, cos term 0. I am not telling that. I am telling that, see, I written here wrong. See, it is half wave symmetry. Like this case, all the odd, not all the even, sorry for that, all the even harmonics is 0. I am not telling cos or sin. I am telling all the even harmonics is 0. So all AC machine waveform is symmetrical with respect to x-axis. Positive and negative axis are symmetrical. So all the waveform in machines will have 0 even harmonics. Now you move ahead. Now you see, take this waveform. No, first take this. For clarity's sake, take this, then we will go here. Take this waveform. First, the positive cycle equal to negative cycle, area DC term equal to 0. First conclusion, DC is 0. Listen me carefully. Now, second conclusion, this is even function. So, even function means only cos term will present, sin term is 0. So, what you will have? Even function. So, cos term plus there is DC term is 0. So, I haven't written anything as DC here. Understand why DC is not written? DC is 0. Average value is 0 because positive axis equal to negative axis area. So it is even function. So cos term exists. It is half wave symmetry. That is, you shift this area here. You shift this area is here. You take negative sign. You will get this waveform. So odd harmonic exists. Half wave symmetry, odd harmonic. Odd harmonic. That is negative equal to negative axis is with respect to x-axis. Positive and negative axis is equal, waveform is symmetrical, so odd harmonic exists. So this waveform will have cos term, and that too only odd harmonics will present. Now you come to here, same waveform is shifted upward, so DC term not 0, area with respect to axis not 0. So same conclusion, DC is present, odd harmonic, cos term. Now take this case, this is odd function, so all sin term is present, sin term is present, area is 0, so no odd harmonics. Now take this this, if you shifted here and take negative cycle, that is with respect to x-axis, that is symmetrical, so it will odd harmonics. Odd is with respect to x-axis, sin is with respect to y-axis. This is the conclusion. Khatam. If you understand this, everything is very simple. This is the overall conclusion you will get while reading signal and system. This I covered in machine also. If you like this conclusion, hit me one like button. I am going to deliver more video with more energy and enthusiastic. See, it is free of cost for hitting one like button, but it will give energy for me to make this video. Now move ahead. Now see, now I told you, take here, due to this waveform, it will have even harmonics during transient. This is the normal condition. Here even harmonic I2 is 0. So during transient, transformer will have even harmonics, and during normal period, during steady state period, there is no second harmonics. See once again, listen carefully. See, during switching, transformer have second harmonic. During steady state, transformer does not have even harmonics. Now suppose take a case of fault occurring. When fault occurred, now current will increase. I mu increases. Now due to switching transient also, if switched at 0 point, current increases. First case, current increases due to fault. Second case, due to switching, current increases. Now the relay which is connected, it has to take a case whether it is a fault or due to switching. If it is due to switching, we have taken the proper care that extra 5 tons is properly graded insulator is used or extra insulation is provided. Second case, extra mechanical strength is provided. So circuit breaker should not open, transformer operate. But if it is a fault, circuit breaker has to open. See the case, see, relay has to work discriminatorily. This is the discriminator property of relay. If it is a fault, current is high. If it is a switching transient also, current is high. But in one case, circuit breaker has to be open when fault is there. When fault is not there, when high current is due to switching transient, we already taken extra care that providing insulation and extra mechanical stability. So your circuit breaker should not open. Hope you have understand what I want to say. So relay has to operate discriminatorily, these two cases. So how relay will identify whether the increased current is with respect to switching transient or with respect to fault? That is, the answer is, tell me, the answer is with respect to I2 current, that is odd harmonics or sorry, even harmonics. This even harmonics exists only when there is a switching transient, and this is 0 in case of fault current. So if it is contain the current, high current contain even harmonics, circuit breaker does not open. When it contain odd harmonics and current is high, circuit breaker open. So this current, so this question was asked in engineering service examination. Switching transient has dominant which harmonic? That is second harmonic, not third harmonic. In any other case, dominant harmonics is third harmonic, but in switching transient, dominant harmonic is second harmonic. So a restraining coil, so during design, see, a operating coil and additional restraining coil, which you will read in power system. Restraining coil is provided to identify whether it is a high current due to fault or due to switching transient. Second harmonic operating relay will be there. You will go and read this in power system about this relay, second harmonic relay, which will identify the fault current and operate the circuit breaker accordingly. Hope up to now the conclusion is clear. Now see the case. This is the GATE 2019 question. What it is telling that in the circuit shown, the value of theta in degrees in which DC component is maximum. DC component maximum means transient condition is maximum. This is the GATE 2019 question. See here, this is the circuit given. This is R, this is L. See here, it is not 0, not sine omega t. Here they have given sine omega t plus theta. So accordingly to this theta, you can say phi. Theta is tan inverse of omega L. This is inductive circuit. You say it as a phi. Suppose phi is given. Now you take the condition of phi also and decide. How you will decide? See, this is the circuit. What is phi? Okay, I took as phi in this question as tan inverse of omega L and theta for sine term. Okay, interchange. Okay, sorry for that. Suppose phi is tan inverse of omega L by R. What you will get? Tan phi equal to 1. So angle is 45 degrees. So if the voltage start at 0, current will start at 45 degrees. Okay, up to now clear. What I told you, this current should start at 0 voltage point, then the transient is maximum. You got the idea? This current should start at, means the current should start flowing. When current will start flowing, switch is closed. When switch is closed at 45 degrees, current will start flowing. Current will start flowing at 0 voltage crossing, then switching transient is maximum. You know, see here, if this is a voltage, if it is 45 degrees, if it is start like this is minus 45, and if it is start from here, this is plus 45. This is capacitive circuit, this is inductive circuit. Up to now, hope it is clear. What is capacitive and what is inductive circuit? This is inductive circuit, minus representing inductive circuit. What is plus representing capacitive circuit? Hope you have learned this in network. if you interconnect networks, signal and system, power electronics, all the subject, if you interconnect and have strong grip, every subject is easy. See here, this question is simple and given in gate, no need to worry. Network also you have learned that. So see, this is 45 degrees, but what we have to do, this point should start current, this is current now, current should start at voltage 0 crossing point for having peak value of DC value, 0 voltage crossing point. So shift this voltage, see this is voltage, current is starting from 45 degrees. How we got this? From here we got this, see from here we got this now, 5 we found tan inverse of XL by R. Okay, this is 45. So it should be, both should be start that at this point if we shift the voltage, suppose this is V2, this is V1, if voltage start shifted from 45 degrees at this 0 crossing point, this will become 0 crossing point, circuit is closed and current start flowing. So DC term is maximum. So for shifting this, what you will add? Minus 45 terms you will add. Answer is minus 45D. Once again I am repeating, see, once again I am repeating, this is voltage, current is increasing from 45 degrees, lag for 45 degrees. What I told you, for having maximum DC effect, current should start, or switch is closed or current is start, both equal meaning, from voltage 0 crossing point. But to have at this point voltage 0 crossing point, you shifted this voltage like this. How you shifted? This angle is minus 45. So answer is minus 45. With respect to machine concept also you can answer. See, once again I am telling, if it is this V1, this is minus 45 lagging and this is plus 45. Hope this concept is clear. You learn this in networks. So hope this gate problem is clear. If you like my video, just hit like button. It take lot of effort to me collect this data from machine, signal and system and from power system. Thank you.